Hello, my name is Libby Barnes. I am the co-chair for the AIA Monterey Committee on the Environment. This is our first COAT webinar of the year. This year, the COAT committee has selected talks and events focused around the AIA Framework for Design Excellence. The framework assists design professionals on how to integrate zero carbon, healthy, just, resilient, and equitable design strategies for their projects. Today's focus will be on design for energy. Speaking on design for energy will be Katie Hallbacher and Nate Russell of Beyond Efficiency, an engineering firm located in Berkeley in Wyoming. Beyond Efficiency brings out the best in buildings with whole system expertise, engineering, and solutions that are optimized for people and performance. Katie is a licensed civil engineer and former Passive House consultant, lead homes rater, certified Greenpoint rater, and certified energy analysis with over 25 years experience. Katie holds a Master of Science in Civil Engineering from the University of Michigan. She is a nationally sought-after expert in the high-performance building community for consulting, training, and speaking engagements, and was a founding board member of Passive House California. Katie believes that adequate planning and collaboration facilitate efficient, common-sense solutions while minimizing change orders, budget overruns, resource and energy waste. Nate Russell holds a Master of Science in Mechanical Engineering and a Bachelor of Science in Aeronautical Engineering from Rensselaer Polytech Institute. Throughout his life, Nate has been involved in many construction projects from simple remodels to full gut rehabs and new construction. Two highlights include designing and executing a full rehab of a 1910 home that included a deep energy retrofit, resulting in 70% energy savings, and designing and building a high-performance home that achieved a HERS score of 39. He draws upon that firsthand construction experience and technical background to facilitate the adoption of high-performance buildings and practices. Today's webinar counts for one learning unit. We will take questions during the meeting, so please raise your hand and we will call on you or put your question in the chat. Okay. Katie and Nate, it's all yours. And just note, we will be recording this presentation, which will be available on our website. I'll stop sharing.
Great, thank you, Libby. Okay, I will get our screen up here. Okay, everybody should be seeing the title slide. Are we good to go? Yes. Okay, great. Yeah, so again, I'm co-presenting with my colleague Nate. We're gonna kind of go back and forth, but I will kick things off. Let's see here. Okay, so Libby already went through. Okay, there we go. Okay, I'm just gonna leave this up there. Oh, by the way, we will be providing the slides, so don't feel like you need to take a bunch of screenshots or take notes. We'll definitely provide these to anyone who wants them. So we already went through the learning objectives. And yeah, just a little bit more about us. So we've prioritized all electric buildings for, I don't know, probably starting 7 or 8 years ago. And we're really happy that, that California and industry and trends have come along. And, it's a great example of that nationwide, not just in California. Heat pumps have been outselling natural gas furnaces since 2022, which is a pretty big deal. I'm not sure when that switch happened in California. It came earlier, but we're definitely seeing great trends when it comes to all electric. But yeah, we work on a range of work and a range of different types of projects, and we're happy to be able to share a little bit with everybody today. So probably kind of preaching to the choir here for anyone who's joining, but there are a number of reasons we love all electric and are really happy that it is becoming so much more prevalent. But health and safety are, we have probably prioritized as the number one reasons. Lawrence Berkeley Lab really as early as 2013 was starting to come out with information on the risks of cooking with gas in a home when it comes to asthma, particulates, and all kinds of things. And the things have been coming so far so fast with new technology, not just the efficiency, but ability for heat pumps to like modulate down. So it's not like it's just on or off or has two speeds, but it has this, really great ability to serve a kind of even kind of an even range of loads from kind of lower to higher. And it definitely is a direction, and obviously from a kind of emission standpoint, best for the planet. So with that, try to get into some more exciting stuff. So I think if you think all electric, you might just go right to thinking of, heat pump water heaters and heat pumps for heating rather than just having, air conditioning with electric resistance or natural gas heating. But we always want to kind of start a discussion by focusing on the notion of kind of how house is a system. We, in our work as mechanical designers, we really look at the envelope as part of the heating system, part of the cooling system. And so I just want to kind of, get that out there and help try to encourage keeping that kind of top of mind. So one example would be, just creating a more compact shape building and using better windows or even, lower percentage of windows. That has a direct impact on reduced heating system size, as well as on reduced cooling loads and reduced cooling systems. And then things that kind of aren't really going to show up in an energy model, but are just real life, is if someone is in a space and it's overheating because the sun's coming in, you close the blind, you turn a ceiling fan on, shed a layer of clothing, and you can often be comfortable without air conditioning. So that's just sort of the underlying premise that we try to kind of bring to our problem solving on these projects. Okay, so I'll love this. I think in 50 years we'll still be saying this, but what's the cheapest kilowatt hour? It's the one you don't need in the first place, and especially in PG&E territory and in Monterey area, 40 cents plus a kilowatt hour is really expensive. And so even more reason to not, I guess, to not forget about the envelope and the importance of the envelope. So it's one thing to use all the sufficient equipment, and that's great, but a better envelope helps homes, helps any building kind of ride through those peaks, whether it's really cold or really hot, in a passive way. And we're going to get more into that. Okay, so yeah, this sort of notion of high performance logic we try to bring to any project, whether we're talking about energy or water use or materials. And if you just apply this to energy, the idea is, well, number one, let's minimize energy demand. Try to get upstream of the problem as much as you can. So yeah, in terms of reducing heating, just again, less fenestration, thicker walls, a better attention to air tightness detailing. And then once you've done a good job minimizing energy demand, and again, obviously this is one of many project design criteria and constraints that architects need to design around. You're looking at views, programming. So it's one of many things, obviously, but in a way that makes sense for a project. Once you've minimized energy demand, then that's when we then want to get into optimizing energy use with things like heat pumps, thoughtful attention to how the systems are zoned, what the controls are, and occupant education and habits is obviously a huge thing. And the final step should then be to incorporate renewable energy based on the minimization and then optimization of energy use. You can end up with a much smaller system, and it's also just a much lower stress on the grid, which is a really big deal for PG&E and our other distribution utilities. Okay, so we're not going to spend too much on Title 24. If there are questions about this, we'll definitely have time at the end to go through things, but just did want to, I think we do tend to still see some confusion about how the code works, and ultimately there are mandatory measures, which obviously have to be done. They're mandatory. Um, and then in addition, there are prescriptive measures, which mean, again, every single item would need to be implemented on a project. If even one of those can't be met, you're then forced into that, the term in the industry is performance. The performance model, we really term it just trade-off model because it's not necessarily encouraging better performance. It's just saying, hey, if you want more windows on the west than you're allowed in maybe a hotter climate zone, the added energy use from that, the added impact on the grid just needs to be, compensated with better performance elsewhere. So it's really kind of a trade-off. And on, in residential projects, yeah, the main things that feed those, the results in the performance model are everything around envelope, as well as the mechanical and plumbing systems. Lighting appliances and plug loads, those are all just sort of default numbers based on kind of federal minimums. So even though these are kind of part of a model, just because, passive gain from lighting and appliances influence how much heating is needed, they you don't get better performance for using an Energy Star refrigerator or something. And then, when we get down to smaller homes and especially ADUs, domestic hot water it's all around domestic hot water. And it is almost impossible to meet code without doing a heat pump water heater. And we'll talk more about that. And we love heat pump water heaters from the standpoint of efficiency and performance. But in a really tiny EDU, the size, it can be a real deal. If you're trying to do a 250 square foot EDU and you are trying to devote 9 square feet to a, heat pump water heater, that can definitely be challenging. So finally, the other thing is, solar is required prescriptively. And there are different, equations depending on climate zone, roof area and other things. But it's really important that on one portion of the energy result it has no impact on kind of the efficiency portion of energy compliance. And energy compliance is stuff continues to get more complicated. It used to just be, a single number, right? The TDV or time dependent valuation. And it definitely is gets more and more complex as the state is trying to grapple with carbon emission reductions and grid resilience and everything. Okay. Oh yeah, I also want to say, I think Libby mentioned this, but we definitely welcome, if you have any questions as we're going, feel free to put them in the chat and we are monitoring that. All right, so let's get into why you're here. So what we feel is like kind of the modern all-electric home. Again, starting with the envelope, high air tightness. It doesn't need to be, some vacuum sealed thing, but certainly higher than is done on the typical project when there is an effort put into it. This has all kinds of great benefits that we'll get into a little bit. And just, general passive principles, thinking about window placement, proper shading, that just trying to, build in some kind of heating and cooling resilience is really beneficial on those extreme days, or when the grid does go out. If a homeowner doesn't have a backup system, it can help again, rather than the inside kind of go like this, it can really ride through those much better. So just, core best practices with passive principles can really go a long way. And then we really like our favorites as mechanical designers ourselves is to have a crawl space and to have that be conditioned, not vented. But it is more expensive, can definitely be more complex, and in areas of high water table that can be challenging. So if there is going to be a slab on grade, insulating it goes a long way. We'll talk just a little bit about that today too, about how much heat loss there is through the edges of the slab, even though code doesn't require it in our mild climate zones right now in California. It really goes a long way. And then unvented roof or a conditioned attic, so an unvented, basically not having openings for fire embers to come in. There's the fire resilience benefit. There's also the benefit, if you have a conditioned attic, of being able to put mechanical equipment there and not have to finagle things in the programming as much. Okay, so then on the system side, heat pump water heater, just given balanced ventilation, heat pump space heating. If you're doing like an air to water heat pump, potentially that can also serve water heating. We're not going to get into that today. it's just overall, it's a more expensive approach where we really like doing hydronic systems with an air to water heat pump. But in terms of bang for the buck and what most projects are doing, most of them are doing just sort of standard air source heat pumps. And again, Nate's going to be diving more into that when we get there. And then other key features of an all-electric home: induction cooktop. This is not a requirement, but we are going to talk a little bit about heat pump clothes dryers, and then finally solar PV and batteries. And Libby mentioned that Nate built his own all-electric home. And if you are interested in learning more about it, he has a really great blog post that talked about that. And this is his home with a mini split right there. Okay, so I'm gonna try to power through the enclosure stuff pretty quickly. And so we can focus more on systems. But yeah, okay. So, but yeah, the little tagline here, get it right from the start. So my kind of big pitch here is, I think in a lot of projects, we tend to put so much effort on the space plan and like, how are we doing the mechanical, what, what are the systems going to be? How are we going to run them? But I really love this graphic. I'm sure some of you probably know about this really great book by Stuart Brand from 1994, How Buildings Learn. And I love this graphic he has in there. It's basically just trying to demonstrate the difference in kind of lifetime of these all the aspects of a building. So the idea is that site is permanent. I mean, it's not really with, climate change and hurricanes and everything, but in general, right, the site is a site in terms of typical wind patterns and climate and design temperatures for heating and cooling. So that is like kind of doesn't change. And then, structure, hopefully this is a 100-year building and 100-year foundation. And then skin. So we're getting into the choice of weather resistant barrier, rain screen, cladding, all of that. And I think, it's the skin where this is generally about, at least a 50-year lifetime. And we would really, we just want to encourage the building industry to not neglect, not neglect the envelope, because again, it really is the foundation of how comfortable a building is going to be, how durable it is, and what those peak heating and cooling loads are. So with that, it's funny because we in the Bay Area, I think there's more and more of this idea that cooling is really the elephant in the room, and that's what leads to kind of most of the utility bills in a year. Space heating does still dominate, and again, always exceptions, right? 3 different projects can be very, completely different, but space heating still is kind of the elephant in the room when it comes to annual energy consumption. And so back to that idea of, trying to get upstream of the problem, if step 1 is to reduce demand for heating from the outset, that's where we want to get into, better windows, potentially, potentially, fewer windows. I know all you architects on here hate to hear that, but windows really are a huge load. So at least being really thoughtful about kind of size and placement can go a long way. But yeah, first we want to reduce the demand, then we want to focus on HVAC systems, because again, we really need to know what the envelope looks like before we can design the mechanical system. So I'm just going to leave this here really as a reference, but this is just a kind of this chart we put together to try to think through the ideal steps for providing great air quality on a project. And one of those is around a reasonably airtight building enclosure. Again, we're not going to get too far into this, but something, a step that we encourage teams to take is to start by looking at typical sections through a building and kind of literally just go around in a systematic way. Okay, where is the airtight barrier in this cathedral roof? And then what are you doing for insulation? Ensure they touch. And then what happens at corners? And then how do you transition to the wall? And et cetera. You kind of, go around, go through this process. And I think often what you find when you go through it is like a lot of things probably haven't been really thought through. And it can go a long way to just doing a better job and having this continuity between the thermal barrier and air barrier. So that's a great first step to ensure a reasonably airtight envelope. It doesn't have to be passive house level necessarily, but what we have found on our projects is just going in with the intention of systematically defining that thermal boundary and then following up in the field. Most projects will actually be at that passive house level of airtightness. So there tend to just be a lot of kind of major things missed when there just isn't that attention put on that goal. And then our favorite approach and what we recommend is to designate the structural sheathing as a primary airtight layer. Most buildings, most buildings are fully sheathed. We every now and then come across projects where there isn't full sheathing, but I'm guessing everyone on this call, you're probably always speccing full sheathing all around the building. And so the nice thing is, it's rigid, it has good integrity, and it's a really great place to put that primary air barrier. So yeah, a lot of our projects use zip system sheathing. You can also do like self-adhered membranes or a rollers brand product. We really like these self-adhered products because they're best for water management, bulk water management, and also double as, again, a great airtightness strategy. And the sheathing is one of the weak points. If you can just, get everything covered with the sheathing, that's a really positive first step. Yeah, and then there's this kind of knowledge product we're working on as a company called Building Genius. And so we're putting a few links to product lists that are in there as a resource for you. Okay, so most of our projects, at least before we're involved in them, are not planning on slab edge insulation. And doing slab edge, this is showing a monolithic slab, but it's pretty typical for projects that are doing slab on grade. But it's true, it adds more complexity to insulate the outside of the slab. Then you have to figure out how are you going to protect it? What do you do at door thresholds and things? But back to that notion of hopefully the structure is a 50 to, or kind of the structure and shell 50 to 75-year lifetime. You want to do it once and kind of be done with it. We feel it makes sense to at least do something here. So if you're looking at a smaller building that's one level and is built on a slab, and you look at the heat losses, it actually contributes more than 30% of the losses, which is a pretty big deal. If you do just a nominal amount of insulation at the edge, you can reduce losses by 20%. If you insulate the entire thing, you can get down to reducing those by about 50%. So definitely encourage insulating the slab, even though it's not required prescriptively by code right now, until you're up in Tahoe. Yeah, and I think, radon isn't really on most people's radar in the Bay Area, but radon is the second leading cause of lung cancer nationwide after smoking. And you get down to Santa Barbara and there's super high radon risk. It's, kind of hit or miss in the Bay Area and Monterey, Santa Cruz. But we really encourage understanding what radon mitigation looks like and just, having it be a given on projects, because it's one of those things, if it's an issue after, it is more trouble to mitigate it. Better to just sort of get some of those future-proofing measures in place first. And and then you can get creative with termite shields. Back to the notion of airtightness, this interface between in this case, the slab edge, or more traditionally, right, it would be on top of the stem wall and the mud sill, is notorious for air leakage. And we encourage doing a really robust material there to help seal it. So one of our, we had a builder we work with who years ago came up with getting pond liner, 60 mil pond liner, inexpensive. You can kind of rip it to whatever width you need. You can potentially even tie it into flashing details. So you can do, kind of a do-it-yourself sort of thing, or you can get, these still gaskets made for that purpose. But yeah, definitely encourage to do more than just nothing, or just the thin little chintzy kind of sill seal that it really doesn't do much of anything. Okay. So, and then again, crawl space, if any of you are still kind of designing in vented crawl spaces, would like to encourage you to study up and understand opportunities to do sealed and conditioned crawl spaces. So that means, eliminate exterior vents, and you insulate walls. You can also insulate the ground, or even just the outer like 4 to 6 feet at the perimeter. Depends on, where exactly the project is and if that makes sense. And then you do this continuous sealed vapor barrier. And then this is considered, again, a conditioned crawl space. It does need to have airflow going into it, but it's not much. It's just 1 CFM for every 50 square feet of floor area. And it can be, you can exhaust from the crawl space or you can supply. And there are different ways to do it, but it's a much better solution than vented crawl spaces. And now with fires being more and more rampant, it's also just a great fire resiliency strategy. Okay, so I'll kind of fly through this. These are numbers. This is just a chart kind of showing the performance of different kind of conceptual wall assemblies. This is 2x4 construction, and then these are all 2x6. And currently, under the 2022 code, the mandatory measure is 0.102, the U factor for 2x4 walls. That these numbers are going up. Well, I should say they're improving a little bit. So the U factor requirements are going down in the 2025 code, which will go into effect on January 1st. But just trying to kind of point out here how much better an assembly gets by adding even just 1 inch or 1.5 inches of rigid outsolation. So kind of show an example of that. And again, we could have a 2-hour kind of discussion and presentation just on kind of wall assemblies and outsolation, but we'll try to keep this relatively quick. But yeah, if you skip that outsolation, it's about 33% more heat loss through the walls. It does improve long-term durability. There are things to figure out, like, are you going to do kind of any windows where you would install like nail flange windows right at the structural sheathing, and then you do the outsolation outboard of that, or do you install the windows in the plane of the insulation? We ourselves, like in any windows, we're not gonna, we don't have a lot of slides on that right now, but yeah, questions about where to place a weather resistant barrier, everything like that. But it's all very doable. This is not rocket science. It's just more being thoughtful about it, and kind of collaborating with the contractor to make sure that the approach works. So, yeah, so again, back to that notion of like, you have 1 time to do the envelope. There's no argument that this is a more complex step and it adds cost. It can add a lot of cost. It's 1 or 2 more times around the building for the contractors. But again, certainly we encourage it, even if code can be met without it. For that back to that notion of like, hey, the shell should be this 50 to 75 year layer of the building. Let's just sort of invest a little more up front and get all the benefits of it for the lifetime of the building. Okay, gotta chat for just a minute about windows. So yeah, obviously, yeah, windows are kind of I don't know, they're what make pretty much any space or building, I think, enjoyable to be in. So they're the super important feature of buildings, and we obviously need them for egress, but there really can be too much of a good thing. So yeah, impacting privacy can make it harder to arrange art and furnishings if you have just those entire walls. But then for us as mechanical designers, it can sometimes be really challenging just to do basic HVAC layout because of rules around locations of, say, operable windows and distance needed for exhaust. It kind of everything around that. So and obviously it can have comfort implications, and it can again directly influence it, not can, but it does directly influence those peak heating and cooling loads. There's some cases where, yeah, windows just make it hard, if not even impossible, to meet Title 24. And then there's a really interesting update coming in the 2025 code, which will limit essentially the peak cooling load. I'm not totally sure how to articulately kind of share the requirement, but it is a distinct kind of shift from any other code so far. So that's we're curious about how some of our projects that we've modeled in a current or previous code will do. And we haven't done too much experimenting yet, but we'll be happy to kind of share updates on that once we know. But anyway, and a lot of this is just driven from the utilities face, obviously, in California, the elephant in the room are those, it's like that 4 to 9 p.m. when things are still really hot, when often is still hot, but then people are kind of like getting home and cooking and everything. And so having higher demand just because of like the design of a building is something they're trying to eliminate or reduce as kind of one of those unknowns or those risks that can make it really hard to manage the utility side of delivering energy. Okay. So yeah, then getting into roofs, not going to go through all these, but just wanted to get all the like options out there for how you can create a moisture safe roof assembly. So most of our projects, I'm sure that it's the case for most of you as well, are doing unvented roofs. And we're a big fan of that, again, for a lot of different reasons. So we're not going to get into roof stuff because I do want to get this turned over to Nate soon. But one of these options you probably haven't heard of is this diffusion open vent. It still acts like an unvented roof, but you actually instead are, and I'm just going to kind of skip through this. This is just giving you again some numbers on different options. But what's interesting is you could do something like, dense packed cellulose on a roof, and you do what we usually would be kind of a vented ridge detail, but you're actually covering this with a vapor permeable membrane, and it allows moisture that collects near the ridges to diffuse out. It can be done from a structural standpoint in the Bay Area. It's not allowed in colder climate zones, but I'll just leave this here for your, again, for reference. We're not going to go through all this, but it is a pretty interesting roof assembly option that can allow you to do a foam-free roof at low cost that still, performs well. So I will leave it at that. And now turn it over to Nate, and I'm gonna advance slides for him. And I guess before we kind of jump into that, are there any questions that have come up that we've missed? Oh yeah, there is a bunch of stuff happening in chat. Okay, so let me just take a quick look at this and see if there are any, oops, sorry. There are any things that we should tackle real quick.
Yeah.
Oh, okay, yeah, so someone was asking about solar water heating. That's one of the first things Nate's gonna be talking about, are heat pump water heaters. So that is definitely one we can talk about. We have our own, opinions and biases about water heating. But that'll be a good discussion. And then yeah, and then kind of another question that I think we could, if hopefully we'll have time at the end again for some more open-ended discussion. And we could get into a more, kind of bigger picture discussion of resiliency and things. Okay, so Nate is on deck.
Sure. So when it comes to DHW and HVAC, I mean, the heat pumps are basically the core technology for meeting these needs. And basically, a heat pump works off of the refrigeration cycle, just simplifying it, extremely simplifying it. Just the refrigerant runs through various pressure and phase changes, and that allows it to either absorb heat or release heat. And the systems are reversible, so you can choose, in a sense, whether you want it to heat or cool a space. These systems are anywhere from 2.5 to 4 times as efficient as just electric, like baseboard or resistant heating, electric heating of any sort. And the heat pumps, yeah, they can be used for either space heating and cooling or domestic hot water. So on the hot water side, there's two options. There's what's called a unitary heat pump water heater, which is shown here. That's where the heat pump is basically sitting right on top of the hot water tank. It extracts heat from the air around it and supplies that to the hot water and warms up the hot water for use. As before, they're 2.5 to 5 times as efficient as a typical electric resistance water heater. Some things to think about though are they can be noisy, though manufacturers are really working on that because there's been a lot of complaints about the noise. They have been very loud, but I know I think A.O. Smith and LG both have models with relatively low decibel ratings, down around 45, which is like a refrigerator. The systems, they require air circulation, so that just means they have to have a constant supply of air to be able to extract that energy. So if they're located in a closet or a smaller space, you either have to add a louvered door or ducting or some sort of means to provide the necessary airflow to the system. They have a cooling effect, and that's just because they're basically bringing in the warm air and pushing out cool air because they've extracted some of the energy from the air. And most systems, they can be programmed so you can set their operation. You can basically schedule them to minimize those drawbacks. So the noise, if noise is an issue or the cooling impact is an issue, you can actually schedule them. So you can say charge the tank when I'm away at work or when I'm sleeping if the noise isn't bothering me that much. And then you just work through that tank for the day, and then it recharges again at night or when you're away at work. If it's located in a closet, it's zero clearance on usually 3 sides, but we typically like to do a 3x3 area just to keep your service and maintenance people happy, whether that's you or you hired that out. And then if you have an ADU, you do have the option of pulling off of the main house system. You can add a recirculation system with some sort of demand control, either a motion sensor or a push button, and that'll save the hassle of having to sort out how to add a hot water system to that space. But if you do take that route, you just have to make sure the hot water heater is sized. It is large enough to handle that extra bedroom or two. So the ideal placement in milder climates where temperatures are going to be over 40 degrees, we typically like to see them in an exterior closet that pushes that cooling effect and any noise concerns to the exterior where it's most likely not going to bother the homeowners, but it's very important that it's only in the milder climates because right around 40 degrees, that's where the system is going to shift over to a complete electric resistance system, and you'll lose all the benefits of the heat pump operation. And the systems, they do lose, their performance does decrease as temperature drops off, but it's a reasonable trade-off just to address those noise and cooling impact concerns.
Yeah, and then we don't have it shown, but we did mention on the other side that there are split systems. So one that I'm sure some of you know or have used is the Sandin or Sanco 2. It's a super high performance, actually CO2 refrigerant based product, and it produces really hot water. And that can be split. So, you have the outdoor unit, which would then run with just a regular pipe, not refrigerant, but just a hot water pipe to the indoor, like to the tank. So that can provide some more flexibility. And, those are more expensive, and there's such a high it's a good fit for kind of larger uses, sort of a normal size home or larger home. For something smaller like an ADU, probably would be pretty hard to justify, but those are great systems. There also is an interesting product called Harvest Thermal that uses that product to also do space heating. So that can be an interesting product to look into if the loads are low enough. That's important, that the heating loads need to be low enough so better envelope. Um, and then do you want to, and Michael, thanks for your comment. Michael had sent it in the chat asking about why there's been not much focus on solar water heating in California, and commenting that in other places such as Israel, every home and apartment has solar water heating. So I'll briefly answer that, and then Nate would love for you to plug in. So there is still solar water heating happening on some multifamily projects. What we found ourselves on smaller projects is, this is one of those technologies. I mean, the technology is great, but the costs really have not come down, and they're fussy to maintain. We often see projects kind of stop working and then they sort of sit there just, dead for decades, literally decades. So our own personal preference is to say, hey, just do PV, maximize the PV on a roof, carports, whatever, and use a heat pump water heater. And you end up with, it's just a really I don't know, it's a system that minimizes complexity. You're gonna probably have PV anyway, to just offset electricity usage. Now, when you get into larger scale projects, I think that's where solar water heating can definitely start to make sense in terms of the technical complexity and maintenance, and the great benefits you do get, because on a per square foot basis, solar thermal panels are better than PV when it comes to water heating in terms of just the amount of hot water you get out of that. So that's just kind of our own, feeling about it. I don't know. I'm not necessarily personally up on this. There could be more solar water heating kind of innovations online that I'm not familiar with, but from what we've seen, it's just kind of hard to justify for those reasons. Nate, do you have any other opinions, or do you disagree?
No, I mean I think just echoing the fussiness and the cost of the system on the smaller scale, I think is a significant barrier, and then just managing the expectations of system operation.
Yeah. And then there's another question asking, kind of indicating, if noise isn't a factor, is there an ideal exterior placement, such as like north, south, east, or west?
No, I think it's going to have trivial impact.
All right, moving on to ventilation.
Yeah. So yeah, with ventilation, there's both continuous and the whole house ventilation and local ventilation required for all single family residences. How much? It's basically the equation is 3% times the floor area plus 7.5 times the number of occupants, which the number of occupants is assumed to be the number of bedrooms plus one. What this looks like is for a 1,500 square foot, 3-bedroom home, you need 75 CFM of continuous airflow. For a 3,500 square foot, 5-bedroom home, it'd be 150 CFM. For your local exhaust, that must be in the bath and the kitchen. And for the bath, that must either be 20 CFM continuous or 50 CFM intermittent. And for a kitchen, it's right around 110 CFM. And there's some variation depending on the size and type of range, but it's right around the 110 to I think 180 CFM in that range. How you can do it in bathrooms, just your typical exhaust fan that can provide your intermittent exhaust. You can also integrate it into your HRV or ERV, which we'll cover in the next slide. For the kitchen, just your classic range hood is the best approach. There is an alternative approach using just a general exhaust fan, but it's not worth getting into the details. I don't think we've ever spec'd it, and I don't think it would be worth it. Just the benefits of the range hood directly over the range. Yeah, it's hard to beat. And then for the continuous ventilation, there's a few different options. So there's exhaust only, which would be basically running your bath fan 24/7 at whatever the continuous flow rate is for the building. We generally don't like that approach because you don't get to control the source of the air. It's just you're relying on the random leaks in the building and you can't filter it. And you also don't have any control over distribution. So um, the ventilation may not be evenly distributed across the building. A step up from that is supply only, and that's where you're basically supplying fresh air into the building. You have an opportunity to distribute that and filter it. Another option is integrating it with your ducted heating and cooling system, but we also rarely specify that just because of the complexity and nuances in balancing the system and intermittent operation of the heating system versus the continuous need of the ventilation system. So it presents some design challenges. It can be an okay solution when all the other options won't work, but again, we rarely specify that type of system. Our favorite and recommended approach is the balanced and independent system. So the balanced system, what that means is it's continuously supplying and exhausting air at the same rate throughout the building. We're supplying fresh air to the kind of living areas like your living room, dining room, and bedrooms, and then exhausting from the dirtier areas per se, like your kitchen or your bathrooms. Using the heat recovery or energy recovery system, what that does is that kind of tempers the fresh air coming into the building and helps reduce the heating and cooling loads as well as improve comfort. So, say in the middle of winter, you're not getting blasted with 35-degree air coming in. Instead, it's tempered to some extent and probably more like a 50 or 60-degree supply air. The ERVs, the difference between the two is that ERVs, they basically transfer some humidity, so there's some moisture transfer, so they'll precondition or kind of balance out the humidity between the exhaust and the incoming flows. And one advantage to the ERVs is condensate drain is not required. And then for the HRV and ERV systems, there are ducted and ductless options. So this is an example of an ADU that has a split ventilation system. We're showing one unit located in the bedroom and then one kind of in the kitchen. And in the split systems, how those work is there's a fan with a heat recovery core at each location, and they operate in opposite directions. So one will be supplying air to the building, while the other will be exhausting air. And then roughly every 60 to 90 seconds, they reverse. And each of those fans, they have the recovery core in there, so that pre-treats that air as it is resupplied to the building. They have filters in them. They meet the MERV 13 requirement, the code requirement, and by distributing them or locating them across the building, you promote that fresh air distribution across the building as well. And typically, using a heat recovery system will improve your compliance margin when it comes to energy modeling. So moving on to the heating systems, we can focus on kind of the three parts, with the first being the plant itself, what's kind of creating the heat or generating the heat. So we can think of that as the heat pump or your gas furnace, propane furnace, or a wood system, or an electric baseboard. We can think about kind of the working fluid that distributes the heat, and that can be air, water, refrigerant, or wires. So for example, with a water system, that might be a boiler system or an air to water heat pump that's going to transfer the water to emitters, or in a mini split system, it's the refrigerant is moving between the outdoor unit to the indoor unit. And then that working fluid is essentially the energy from that is extracted to deliver heat to the space through either fan or fan coils, just the surface temperature difference itself, a radiator, or something like a fireplace. So again, like a mini split, if you think of a mini split system, that's basically refrigerant going from the outdoor unit to a fan coil in the indoor unit, and that those fan coils can be ducted or ductless. And this shows an example of some of those systems. So if we look at the kind of the bottom four here, those are all ductless systems. The left two, those are wall-mounted ductless systems, and manufacturers, they seem to be, they're arguably room to grow still, but they seem to be doing better with offering more sleek and aesthetically pleasing ductless options, so it doesn't look like a big chunk of white plastic on the wall. The unit on the left it's called the LG Art Cool system, and that's specifically designed to incorporate a piece of artwork or a photo over it to help hide the system. The two systems to the right, those are recessed ceiling systems. So they, yeah, just as it described, they sit up in the ceiling and you just see the white grill um, sitting at the ceiling surface. And then the one at the top, the rectangular, um, thinner looking one, that's called a slim duct system. And those are designed to fit nicely into a drop ceiling or a soffit. And they typically require about 8 to 10 inches of space and can simplify those those installations and allow you to duct the air to wherever you need. And then the top three units in the right, those are just what your outdoor system looks like. And there's single zone and multi-zone systems where you can have any of these. You can have 1 to 5 indoor units running off of one outdoor unit. That being said, we tend to avoid the multi-split systems where you have multiple indoor units running off of a single outdoor unit, or not avoid, but limit them just due to load matching. We want to make sure that the zones, that the capacity of the zone is matched up to the load of the system. Where this really comes into play is particularly with bedrooms where the loads are so low compared to the minimum output of both the outdoor unit and the fan coil itself that it can present kind of comfort issues and efficiency issues. So we really like to avoid adding a ductless system to each room. And one last point is these systems required field refrigerant work, so you have to connect the refrigerant line from the outdoor unit to each indoor unit. And this is of the service calls, this is probably the top service call for system malfunctioning is the refrigerant work was not done properly. So the refrigerant has leaked out and the system is no longer providing heating and cooling. And one way to avoid that or get ahead of that is just to request or require your installers to provide documentation of their vacuum and pressure testing, both the values and the duration, just to be able to confirm that it was properly done. There are also package terminal heat pump systems, and as the name describes, it's a package system. There's no field refrigerant systems, or there's no field refrigerant connections required. All the refrigerant work is done at the factory. These units, they basically sit on the wall. They're roughly 2.5 to 3 feet wide by 2 feet tall and maybe 6 to 8 inches deep. They require 2 holes to the exterior, and they can either run on 120 volts, so a standard wall outlet, or a 240 volt circuit. So they greatly simplify the installation process, and they're great for ADUs or small additions where it's not always easy to extend the existing heating and cooling system. Next slide.
Good. Sorry.
Another relatively new option is the air to water heat pump. Instead of circulating refrigerant to an indoor fan coil or distribution system. Again, all the refrigeration cycle is handled at the outdoor units, factory sealed, and then the system actually circulates cooled or heated water to the space. And it requires a few more components like a buffer tank and manifolds, but it can supply heating and cooling via like radiant floors or fan coil systems, or essentially ducted system. On the cooling side, there are options to do chilled ceilings or floors, but those have to be carefully designed, and the capacity is limited, and that's mainly due to limiting the condensation risk.
All right, I'll leave a little bit of time for questions. Let's see, I'm gonna just jump in some little bit of extra info on what we're calling kind of accessories. I'm not sure if this is going to work. We'll try. So this is a great video. So we worked on our title slide, you saw the picture of that fire rebuild. This was the fire that went through the Santa Cruz Mountains in 2020. Was that when it was? It's hard to keep everything straight now. But this was a fire rebuild for this, really, really lovely couple. And they were kind of demoing their induction cooktop for us last summer. So let's see if this works. Great. All right, so Dave and Alexandra, here you are in your new home after the huge fire that came through. And I see that you have an induction cooktop. So what were your first thoughts when we talked to you about doing induction?
I was resistant because I've spent a lifetime cooking with gas. I've had high-end gas stoves and cooktops that I really liked. And I had no idea what induction cooking was like. But I'm so glad that you talked us into it, because this is wonderful. It's very responsive. It's very easy to clean. And this particular model is great because it remembers the setting of the pan that you're working with. So if I were to move this over here, it tracks that I have moved it over there, and then I can put another pot, say over here,
Different size.
of a different size, and I'm just gonna turn this on. Otherwise it will not see it. Anyway, you can move this over here and put another one over here. And the best part about this cooktop is that there are no set burners. I can move it around any way I like.
That's amazing. Thank you.
Let me know. Oops. Let me know.
Uh-oh. Okay, there we go. Yeah, so I'm sure, probably everyone on this call is probably excited about induction. And I will know not all cooktops are that smart where you can move a pan around, but it is really amazing what you can do. And, they didn't mention this, but I have 3 boys. We never had a burn from a stove incident, but I feel like I can think of 2 classmates through the years that did. I remember this little girl showing up to like this daycare, 8 years ago or something, with like this massive thing on her hand. So just the safety benefit of induction, I think it's hard to overstate that. Okay, so we'll try to power through to have a little bit of time for open Q&A here. But yeah, heat pump dryers. So these are ventless dryers. This can be a really great solution for retrofits where it's really expensive and complex to get a proper kind of, dryer duct routed and done in a safe way. So essentially these work by condensing moisture and draining them. There are condensing dryers that don't have the heat pump technology, but the heat pump definitely does make these work better. So we would encourage that. But if you are going to pursue these or look at it for your any of your projects, it's just super important to know what to expect. And I think there's an education aspect that's super critical with these. If you're going to drying a bunch of heavy towels or blue jeans, you want to do small loads. It'll take a long time to dry. And all things being equal, they do require more time to dry. So something we do in my household is we try to do a mix of sort of synthetics, athletic stuff, wool with cotton, so that then we hang about half the load and put the other half in the dryer. So anyway, but yeah, it's a really good technology. Something we like when it comes to the mechanical side in just kind of overall indoor air quality is because these don't vent. When the dryer is running, you're not exhausting it's usually about 150, maybe even 200 cubic feet per minute of air, which then, the makeup air comes from the rover. And if there's a wildfire at the moment and you don't want to be depressurizing the home and bringing in more air that isn't properly filtered, it's, not a great thing. So there are other benefits like that as well. But these are different from, your natural gas dryer or electric resistance that will just sort of toast your clothes and have them dry in 30 minutes. But yeah, just again, really important to read the manual and understand like kind of best practices for drying different types of loads. So that's a great part of the all electric solution. And yeah, we do have a list of some products in Building Genius as well. And then just a quick thing on some Title 24 PV and battery requirements. There's some slight shifts between the current code and 2025, but the only one of kind of consequence we're aware of is that there is going to be an exception for battery ready if the existing service is under 125 amps. And this is just an excerpt from the code. But essentially, like when your Title 24 consultant runs a performance model, there will be one of the calculations in there will be the kind of required PV. There also is a direct equation you can do. Nate, please correct me if I'm wrong in any of this. But yeah, and if you're doing an ADU in climate zone 3, because of an exception, this sort of equation works out such that if your conditioned floor area is less than 1,083 square feet, there's no PV requirement. Of course, we would still encourage it, and hopefully that still happens, but it's not actually required per code. And yeah, I know, I realize we're getting close to time here.
What's on your next slide? Can we,
yeah,
because we're also going to share out these slides with everyone. So.
Okay. Yeah. And this is just, there is a battery rebate program that you have. There are some other all electric rebates as well offered by Central Coast Community Energy. The clients you just saw who were showing off their induction cooktop, they got a $15,000 rebate for rebuilding all electric, which they were really happy about given the crazy increases in costs that came through when they built. But so yeah, this will be there as a resource. And then these will also just be there as a resource, some follow up on like, what do you do in an electrification scenario where a client comes, hey, we want to electrify, we want to get rid of gas as part of this remodel. But in general, you can almost always find a way to not have to upgrade the panel if it's 100 amps or larger. If it's older, smaller, there's some really old, dangerous panels out there that you want to get rid of anyway. But yeah, we'll just sort of leave you with some of these resources that will be in the slides that Libby shares. And that's it.
Great, thank you. Yeah, I'm going to leave this slide up. I was going to share out pretty much the same slide. So does anyone have any questions that they'd like to ask Katie or Nathan live?
If you don't mind, I'll just catch up on one that came in the chat.
Yeah.
Someone asked, so there are changes to there are older certain refrigerants are being phased out in California. The question is, how does that impact single family? So we could share a lot about that. Nate, do you want to kind of answer that? What do the refrigerant code changes mean on California projects?
Yeah, so the systems are going to require the updated R32 or 454 B systems, and the installers and service providers are all aware of this and working on that. There have been I've seen some anecdotal concerns about refrigerant shortages, but I don't think it's of a major concern, and equipment should be available.
Yeah, and something to be aware of, something we've dealt with on at least one project was having plans completed and then the project sits there. And then by the time installers are brought on board, then they can't find equipment that was originally specified, and so we kind of have to do a switch. So, there are just some things like that to be aware of. You think that equipment is relevant based on the timeline, and then 6 months later, it has to be updated. So there's some things like that that are just the reality, but otherwise very all solvable challenges.
Great. Thanks for answering those questions. I'm going to close it here. So really, thank you guys so much for joining us today. Thank you for those that took their lunch out and attended. Last thing I'm just going to share out. There's a lot of great resources out there about just what Katie and Nathan have talked about on the AIA website. Also, just look for updated events that are happening on the AIA California website. And again, would love to have new COAT members join us. So please reach out to myself or Selena if you're interested. All right. Thank you again to Katie and Nate, and see you at the next one.